Dive into the depths of innovation as NASA unveils its extraordinary creation, the underwater rocket known as the Sea Dragon. Join us on a mesmerizing journey where cutting-edge technology meets the enigmatic realm of the ocean as NASA pioneers a groundbreaking approach to space exploration. Prepare to be captivated as we unveil the secrets of this aquatic wonder, igniting your imagination and propelling your curiosity to new depths. The Sea Dragon was a 1962 conceptualized design study for a two-stage sea-launched orbital super heavy lift launch vehicle. The project was led by Robert Truax while working at Aerojet, one of several designs he created that was to be launched by floating the rocket in the ocean. Although there was some interest at both NASA and Todd shipyards, the project was not implemented. With dimensions of 150 meters, 490 feet, long and 23 meters, 75 feet in diameter, Sea Dragon would have been the largest rocket ever built. As of 2018, among rockets that have been fully conceived but not built, it is by far the largest ever, and, in terms of payload into low Earth orbit, LEO, equaled only by the Interplanetary Transport System concept, the predecessor to SpaceX Starship. In the latter's expendable configuration, with both designed for 550 tons. Design. Truax's basic idea was to produce a low-cost heavy launcher, a concept now called Big Dumb Booster. To lower the cost of operation, the rocket itself was launched from the ocean, requiring little in the way of support systems. A large ballast tank system attached to the bottom of the first stage engine bell was used to hoist the rocket vertically for launch. In this orientation, the payload at the top of the second stage was just above the waterline, making it easy to access. Truax had already experimented with this basic system in the CB and Seaforce. To lower the cost of the rocket, he intended it to be built of inexpensive materials, specifically 8mm steel sheeting. The rocket would be built at a seaside shipbuilder and towed to sea for launch. It would use wide engineering margins with strong simple materials to further enhance reliability and reduce cost and complexity. The system would be at least partially reusable with passive reentry and recovery of rocket sections for refurbishment and relaunch. The largest rocket ever designed, the rocket in question, it's called Sea Dragon, and it's not just another product of Hollywood trying to make rocket science more entertaining than it was in real life. It was a very real-world design study that took place even before the Apollo program had gotten off the ground. Today, let's take a deep dive into the real-life and fictional exploits of Sea Dragon, the most ludicrous design for a booster rocket that never jumped off the drawing board. Because claims like this are nothing without numbers, let's take a look at a tale of the tape. We're gonna need some extra long tape measures this time around. With a diameter of 75 feet, 23 meters, and a projected height of a staggering 490 feet, 150 meters, and weighing in at just under 40 million old, 18,143 tons, Sea Dragon was designed like a freight train with a rocket engine. Its potential to bring 550 metric tons, 1,210,000 pounds, to low Earth orbit, LEO, certainly sounds like freight train numbers. That was essentially the idea when the Sea Dragon's lead engineer Robert Truax finalized the blueprints for the design in 1962. Under the employment of the Aerojet company that one day merged with Rocketdyne, Truax proposed an alternative to conventional super heavy booster rockets with lots of complicated engines. Why the water rocket? NASA's endeavor to develop a water rocket stemmed from a combination of scientific curiosity, technological innovation, and educational outreach. By harnessing the power of water as a propellant, NASA aimed to explore alternative propulsion methods that could potentially be utilized in future space missions. Water rockets offered a unique platform for studying the principles of rocketry, fluid dynamics, and aerodynamics in a safe and accessible manner. Additionally, these rockets provided an engaging way to capture the interest and imagination of students and the general public, inspiring them to learn about the fundamental principles of space exploration and fostering a passion for science, technology, engineering, and mathematics, STEM education. Through the pursuit of water rocket technology, NASA sought to ignite a spark of curiosity and inspire the next generation of space explorers, while also advancing our understanding of propulsion systems and expanding the boundaries of human knowledge. How did NASA's Sea Dragon rocket work? The NASA Sea Dragon rocket was a colossal and ambitious concept designed to revolutionize space exploration during the 1960s. The rocket's unique working principle was based on a combination of simplicity, scale, and innovative engineering. Standing at a towering height of 150 meters, 500 feet, the Sea Dragon utilized a vast fuel tank, partially submerged in the ocean. This immense tank, capable of holding an astounding 9,000 metric tons of liquid propellant, functioned as both the fuel reservoir and the rocket's main structural element. By utilizing the ocean as a launch pad and taking advantage of buoyancy, the Sea Dragon leveraged the principle of displacement to achieve liftoff. Once the rocket's engines ignited, the propellant was rapidly consumed, shedding the weight of the fuel tank and enabling the rocket to soar into space. Despite never being realized, the audacious Sea Dragon concept showcased NASA's bold vision for pushing the boundaries of rocket technology and exploring innovative methods to reach the stars. The future of NASA's sea launches. The future of NASA's sea launches holds great potential for expanding our understanding of the universe and advancing space exploration. With the increasing demand for satellite launches and deep space missions, sea launches offer several advantages over traditional land-based launches. Sea launch platforms can provide more flexibility in terms of launch trajectories, allowing for optimized orbits and reduced fuel requirements. They also enable launches from different latitudes, providing a wider range of access to space. Additionally, sea launches mitigate concerns over potential launch hazards to populated areas, making them a safer option. As NASA continues to innovate and develop sea launch capabilities, we can expect to see an increase in the frequency and efficiency of launches, opening new frontiers in scientific research, satellite deployment, and human exploration. The future of NASA's sea launches promises to be an exciting chapter in our quest to unlock the mysteries of the universe and expand our presence in space. As we conclude this captivating journey through the depths of the video on NASA's underwater rocket, the Sea Dragon, we are left in awe of the audacity and ingenuity of human exploration. This remarkable rocket, designed to conquer the depths of the ocean, represents a bold leap into the unknown, pushing the boundaries of our imagination and technological capabilities. If you found our video informative, kindly subscribe to our channel so you won't miss out on our videos.